All right, let's do that first example on page 2 of the packet. This is the wave, I guess, example practice kind of thing. I'm going to show you the example and then I'm going to set you up for the practice. So the example, let me read it to you quick. A periodic wave on a taut string completes a single 0.24 meter wave every 0.6 seconds. So the 0.24 meters, they're telling me, is the wavelength. A single wave means they're telling me the wavelength. If it said a half a wave, well then that would be half the wavelength. Okay, so they told me it was the full wave was 0.24 meters. That's how I identified it as the wavelength. Now they said one every, okay, once every, that's telling me the period, the time for one wave. So remember when we did rotation, it was rotations per second, the time for one rotation. Now we're talking about the time for one oscillation, okay? And so they gave me the period, plug it in to find frequency, which is what they want me to find first. So 1 over 0.6 gives me 1 point, what was that number? 1.67. And hertz. And so this is where hertz comes in a little stronger than before. When we did rotation, hertz was talking about rotations or revolutions per second. Here it's talking about oscillations per second. And so that's where hertz has that variability. They can talk about different types of things. All right, now I'm going to use that frequency. It wants me in part B, what is the speed of the wave? So I want to find V. And remember when I say speed of the wave, I'm talking about the speed of energy. Remember, energy is the thing that moves. A wave, it just goes up and down, but energy is the thing that's moving. So when we say a speed of a wave, we're talking about the speed of the energy of the wave. So in order to find that, I need the frequency and the wavelength. I have both of those. So I have my 1.67 times my 0.24, and I end up with a speed of 0.4 meters per second. And again, this is how fast the energy is moving, because the whole idea of waves is waves transfer energy from one point to another. Let's set you up on your example. So in the ocean, we have waves that transfer energy. Again, that's the wind pushing on the water typically that causes these waves. You might say, is there anything else? Boats, people, anything can cause a wave. Tides, seismic activity. But for the most part, yes, wind is the culprit. So wind transfers energy to the water, and then that water transfers that energy across the ocean with waves. And so we have our fisherman in his boat. He's going up and down, and he notices that the distance between the crests is 7 meters. And he notices the difference between a crest and a trough is 6 meters. They are asking you to find amplitude. And remember, amplitude is from some equilibrium location. So if you want to find the amplitude, and they give you this distance, you know what to do. Also, the other thing that they tell you is they tell you the time it takes to go from this point on the wave to this point on the wave. Is 2.5 seconds. But remember, period is the once every. So it's the time it's going to take to go from this peak and come to the next peak on the wave. Okay? All right, so there's your hint. Go ahead, give that practice a try.